Hey guys, welcome back. My name is Mr. A, and I'm here to help you out, this time with equivalent ratios and fractions. Why fractions? You'll see in just a second. So first, let's go ahead and talk about how do these things work. How do fractions and ratios work as far as their equivalents? Well, an equivalent ratio or a fraction, this works both ways, all they are is a simplified or expanded version of an original fraction. There is not much more to it than that. However, rather than just stand here and talk to you about it, let's go ahead and do a couple of examples just to make sure that I drive the point home. To the bat table! Okay, here we are at the bat table. What we're going to do is we're going to start with an original fraction, and then we're just going to start expanding from there. So let's go ahead and start with 2/5. Sounds fair enough. So here we have 2/5. This is what I would call my 1 times part of my table. What I mean by that is this fraction or ratio is already written in its most simplest form. You cannot simplify 2/5 any farther than that. It is stuck at its original place. The reason that that's important is that each one of these sections of the table represents another piece of what that can be multiplied to. Let me give you an example. I'll show you what the second part of this table is supposed to look like. Now I hope you're starting to catch on to what I meant by my 1 part of my table and my 2 parts of my table. The 1 part of my table is if I take my original fraction and multiply it by 1. If I take 2/5 and multiply it by 1, I'm going to remain at 2/5, my original simplified answer. The way I can expand that to get a new equivalent fraction is simply take my numerator and denominator, or if we're talking about ratios, I can take one side of my ratio and my other side of my ratio and simply multiply them by the same amount. As long as I am doing the same thing via multiplication or division on both sides of my table, it is perfectly acceptable. Let's go ahead and talk about the rest of this table. What do you think that my next part should be? Do you think I should multiply by 3? Let's give it a shot. Hopefully you noticed something about what I just did. I'm not looking at my second part of my table. I'm looking still at my original piece of my table. Why is that? Well, partially because that was my original. Why would I take a copy of my original and start working from there? Doesn't make much sense. What I want to do instead is constantly refer back to my original ratio and base everything else off of that. So, the rest of my table should look a little bit more like this. At the end of it, my whole table is just going to be me multiplying by a different amount my original ratio. So, take a moment, think about what's going to go in that 4 times table. You got it? You're already done with that whole table, aren't you? How about this? Let's go ahead and fill in the whole thing. So there is one other piece that you may have started to notice as you were writing and filling in this table. All I'm doing, as far as this side of my table is concerned, I'm simply counting by 2s the whole way down. As for the other side, I'm counting by 5s all the way down. Well, there's no real mystery there. If you take a look at my original ratio again, you'll notice that my original ratio started with a 2. That's kind of giving you a heads up that every single number, all the way down, if you are continuing to just go as 1, 2, 3, 4, 5, you're just going to be counting by 2s. As for the other side of the table, its original starting point was a 5. That's giving you a heads up that if you're still going in order, all of these numbers are just going to be counting by 5s. But let's take a look at another example. What if you take a look at your original ratio and notice it's not in simplified form? You take a look at, let's use the example of 6/14. Well, 6/14 both have a common factor. They're not simplified yet. So we're going to have to leave a blank spot near the top of our table to make absolutely certain that we have space to put our original ratio. Let's go ahead and check out that example. So as you can see, I went ahead and wrote 6/14, but I didn't fill in what it was being multiplied by because, well, we haven't discovered what the original simplified answer is. Can you figure it out? I have. Let's go ahead and fill in this table and see what it was. Okay, so hopefully you were able to come to the conclusion that you had to divide 6 and 14 by 2 in order to get your original ratio of 7 to... I messed that up. To get your original ratio of 3 to 7. So, now that I know that this is my simplified form, I went ahead and I filled in the side areas, labeling both of those sides as my one-time box. That box represents my original simplified ratio. It doesn't get any farther simplified than that. So, from this point on, it's just a matter of filling in the rest of the table. You don't even have to count by 1, 2, 3, 4, 5 if you want to. Let's go ahead and jump right in, make the third one 3, shall we? If you decided to take this one and turn it into your 3 times table, well, again, 3, 6, 9, 7, 14, 21. There's not much to it. Let me throw a curveball at you real quick. What if I made that next one 5? Can you figure that one out by yourself? Go ahead. Figure it out. In the meantime, let me go ahead and show you what it is. Alright, so did you get 15 to 35? How about this? What if I gave you the next one, but all I did was tell you one number? Let's see. Can you figure this one out? So the only piece of information you have right now is the rest of this table and the number 70. I'm not telling you what goes in that box for a little bit because I want to see if you can figure it out. Think about it. What am I having to multiply that 7 by to get 70? Did you figure it out? Well, if you got 10, you're right. All I had to do was multiply my 7 by 10 in order to get 70. Well, if you notice the rest of this table, you'll notice that we're having to multiply the same thing on both sides. So if that side of my table is multiplied by 10, that means the other side must have been multiplied times 10. And 3 times 10, you're right, it's going to be 30. And that's it. That's all there is to knowing about equivalent ratios, as well as equivalent fractions. Everything that we just talked about here is perfectly applicable to fractions too. Alright guys, that's all the time we have for today for equivalent ratios and fractions. I hope you found this informative and I hope it helps you out down the road. Have a nice night.